So in general, for any real number, capital R, the sequence r to the nth power over n factorial from n equals 1 to infinity does converge to 0. And what you're utilizing here that makes it happen is because eventually we can find a number m greater than the absolute value of this number r. And so what we can actually do is show that the sequence absolute value of r to the nth power over n factorial will converge using the same trick as this. So I'll have some initial product of the first m minus 1 terms, and I can sort of treat that like my constant, or my a, if you will, in my geometric sequence. And then all the terms after that, I'll replace with r over m. So that'll be raised to it's always n minus m minus 1 power, but this is still a geometric sequence. And because of the fact that the absolute value of r will be smaller than m, this is a geometric sequence with that ratio less than 1, and so it will converge to 0. And so I can take the absolute value of the sequence I was looking at and set it less than or equal to that. And we established that using the squeeze theorem, if this converges to 0, and that converges to 0, and now we get that this converges to 0. When the absolute value of a sequence converges to 0, that implies the original sequence, r raised to the n power over n factorial, even if r is a negative number, will converge to 0. Sort of by a double squeeze theorem. And let's look at an image of that. We'll just try out a couple different values of r here in Excel. All I'm going to change is what r is. So let's try r equals 10. We can see that we have a lot of values that start out with where the overall sequence terms are still growing. We see that we grow up until here at 2755. Now the reason is because once we get to the 10th term, 10 over 10 is 1, but 10 divided by 11 is less than 1. So at the point that we hit the 11th term and every term thereafter, as we go to a higher term in the sequence, we're multiplying by 10 over a number bigger than 10, and it starts to shrink. So while it does it much more slowly, we still have that this particular sequence is going to converge to 0. And I encourage you to try this with other examples to see that no matter what r is, we get this result.